Hey, Mrs. Radigan here with a lesson on solving rational equations. The definition of rational equation, the steps for solving, and the definition of a least common denominator are here. As you can see, when you solve rational equations, you want to multiply both sides of the equation by the least common denominator. So if we had 8 and 6, the least common denominator would be 24. If we multiply 1 over 8 by 24, that simplifies to 3. If we multiply x over 6 times 24, that multiplies or simplifies to 4x, and then we can just solve this equation using our reverse PEMDAS. So we would just divide by 4 and we would get x equals 3/4. Remember, you need to use the least common denominator, so the smallest denominator that both denominators are divisible by. So we could have used 48, but 24 is the least common denominator, and that becomes important when you have a lot of x's and big polynomials. You always want to check for extraneous solutions, because when you're doing this process, you can create those extraneous solutions when you multiply both sides by the same algebraic expression. So let's go ahead and do the first example. So the least common denominator in this particular problem would be 3 times x minus 2. So if we want to multiply both sides by the least common denominator, we would multiply by a factor of 3 and a factor of x minus 2. And we would multiply by a factor of 3 and x minus 2. Now some of these are going to cancel. So x minus 2 and x minus 2, and 3 and 3. So we're left with x times x minus 2 and 1 times 3. So that becomes x squared minus 2x equals 3. To solve that, we would just move everything to one side. So x squared minus 2x minus 3 equals 0. And solve the polynomial by factoring. So minus 3 plus 1. And we set each factor to 0. So x equals 3 and x equals negative 1. Now we would want to check those to make sure they don't create extraneous solutions. So 3 over 3 equals 1 over 3 minus 2. 1 equals 1. And negative 1 over 3 equals 1 over negative 1 minus 2, which is both negative 1/3. Okay, in example number 2, our least common denominator is 2x. So we would multiply both sides of the equation, or every term actually, by 2x. So this gets multiplied by 2x, this gets multiplied by 2x, and this gets multiplied by 2x. And we can simplify x over x, 2 over 2, and 2x over 2x. So we're left with 2 times 1, which is 2, and x times x, which is x squared, and x plus 4. If we move everything to one side, x squared minus x minus 2 equals 0. Factor and simplify. X minus 2, x plus 1 equals 0. And we get x equals 2. And x equals negative 1, and we would want to check those solutions. Number 3, our common denominator, since this factors to x minus 2 times x minus 3, is going to be x minus 2, x minus 3. So we would multiply this side by x minus 2 times x minus 3, and we would multiply this factor by x minus 2, x minus 3, and this factor by x minus 2, x minus 3. So we would get the minus 2 in this one to cancel, the minus 3 in this one to cancel, and all of this is the same as x minus 2, x minus 3. So we're left with x times x minus 3 plus x times x minus 2 equals 3. If we multiply that out, we get x squared minus 3x plus x squared minus 2x equals 3. And we move all that to one side. We get 2x squared minus 5x minus 3. And that factors, you might need to use your factor square. Factors of -6 to add to -5 would be -6x and 1x. And that would give us a 2x, x minus 2, and then x minus 3 and plus 1. So this factors to 2x plus 1 times x minus 3. So that gives us solutions of -1/2 and 3. Now x equals 3 is the denominator in this fraction right here. So there's no way that can work because that would create a 0 in the denominator. So we know right away that this one is extraneous and this is our only solution. In example number 4, we have an x plus 2, and then we have an x squared minus 4 that factors to x minus 2, x plus 2. And then this one has an x minus 2. So our least common denominator is going to be x minus 2, x plus 2. So we're going to need to multiply every term, or every expression by x minus 2 times x plus 2. Multiply this by x minus 2, x plus 2. Multiply this by x minus 2, x plus 2. And then we simplify. So the x plus 2 cancels. X squared minus 4 is x minus 2, x plus 2. And the x minus 2 cancels over here. So we're left with 3 times x minus 2 plus 12 equals -1 times x plus 2. So if we distribute, we get 3x minus 6 plus 12 equals -x minus 2. And if we combine like terms, we have 3x plus 6 equals -x minus 2. So 4x equals -8. and x equals -2. We'd want to check that solution. That is actually a restriction on the domain, because in our original problem, x plus 2 was a factor of the denominator here and there. So that means x cannot equal -2. So this is actually an extraneous solution, and there are therefore no solutions to this problem. Okay, in this problem we have this right here that factors to x plus 5 and x plus 2. We have a common factor of plus 2 and plus 2 here, and we're close to having an x plus 5 there. So if we just take out a -1 and make this x plus 5, then we can have a least common denominator of x plus 2 and x plus 5. I'm going to move the -1 to the top so we don't have that as a denominator value. So we're going to have 5 over x plus 2 equals -1 over x plus 5, x plus 2. And then we're going to have a -3, I'm moving that negative to the top, over x plus 5. So if we multiply by our least common denominator, plus 2 plus 5 here, plus 2 plus 5 here, and plus 2 plus 5 here. We get the plus 2's to simplify, both the plus 2 and the plus 5 to simplify, and the plus 5 to simplify. So we're left with 5 times x plus 5, just a negative 1, and then a negative 3 times x plus 2. So if we distribute, we will have 5x plus 25 equals negative 1 minus 3x minus 6. And if we combine like terms, we will have an 8x here, and a negative 25, a negative 1, and a negative 6 makes a negative 32. And so we get x equals negative 4. And if we look at the denominators, we don't have any that are restricted in the denominator. You can check the full equation, but most likely this is our solution of x equals negative 4. So in summary, you need to solve rational equations by multiplying both sides of the equation and each of the fractions by the least common denominator to clear out all those denominators. And then you just solve using reverse PEMDAS. And make sure you check for extraneous solutions.